Hi guys, this video is on solving rational inequalities. So remember, rational expressions or equations have a polynomial on the top and the bottom of a ratio or a fraction. So the way we're going to solve this is very similar to how we did the polynomial inequalities yesterday. So our first step is we want to find the critical values. Now in this case, the critical values may be in the numerator or the denominator. Okay, so we want to do both. So from the numerator here, we have x minus 6. So if I were to set that equal to 0, what would x have to be to make that equal 0? That would be positive 6. I'm going to change colors, that's a little light. On the denominator, I have x plus 8 equals 0. So if I subtract 8 from both sides, we would have x equals negative 8. So my two critical values are 6 and negative 8. Okay, again, you're going to find them from the numerator and the denominator. Now, for the numerator, I'm going to look at the inequality to find whether I circle it or with a filled in circle or with a open circle. Okay, now on the denominator, so when I have over here when I circle 6, so I'm going to do 2, 4, 6, 8, and then I'm going to do negative 2, negative 4, negative 6, negative 8. Okay, now over here when I circle these, I'm going to want to circle 6. To determine whether to fill it in, I'm going to look at my inequality. And that one says or equal to, so I will fill that one in. But when it comes to the denominator, remember, I never want anything in my denominator to equal 0. Because if my denominator equals 0, then this is undefined, because I cannot divide by 0. So if it comes from the denominator, it's always going to be an open circle. So I'm going to circle negative 8. And it's going to be an open circle this time because it came from the denominator, okay? So find the critical values, put them on a number line. Okay, so circle critical values. And then my third step is just like before, I'm going to check each interval to see if the inequality is true. Okay, so just like yesterday, I want to take values from each interval and I want to plug them in and see if they're true or false. So for this one, I could do negative 9, negative 10, negative 100. As long as it's in this interval, it doesn't matter. So I'm going to try negative 10. So negative 10 goes where x is here and here. So negative 10 minus 6 over negative 10 plus 8 is less than or equal to 0. Let's see if this is true or false. So negative 10 minus 6 is negative 16. Negative 10 plus 8 is negative 2. Negative 16 divided by negative 2 is positive 8. So positive 8 is not less than or equal to 0. That's not true. That's false. So I will not be highlighting this part of the function. Now I need to check the middle. So I'm going to plug 0 in because 0 is always quick and easy to calculate. So 0 minus 6 over 0 plus 8 is less than or equal to 0. This would give me negative 6 over 8, which is a negative number, and negative numbers are less than 0. So these are true. So this interval will get highlighted or shaded in. Okay, and then I would want to check my third one. Most often they always switch from false to true to false, but not every time. Occasionally you may get two true intervals in a row, so we do need to check. So I'm going to plug 8 in, but you could do 8 or 10 or 12 or 11 or anything bigger than 6. Okay, so let's go ahead and plug 8 in. So that would be negative 10 oops, no it wouldn't. It would be 8 minus 6, just plugging it in here. 8 minus 6 over 8 plus 8. And my inequality says that should be less than or equal to 0. but that gives me 2 over 16, which is a positive number, which is not less than 0, so that's false. So my solution would just go from negative 8 to 6. I would want an open or round parenthesis on the negative 8 side and a closed bracket on the side with 6. Okay, so let's go ahead and try another one of these. So I've got x plus 3 over x minus 5. So first step, find those critical values. If I were to set the numerator equal to 0, my x that would make that equal 0 would be negative 3. And for the bottom, x minus 5, I would get a critical value of positive 5. So here's negative 3. Here's 5. I'm going to circle in a different color here. So remember, this one came from the numerator, so I would check the inequality. Since the inequality says or equal to, I'm going to circle that one and fill it in. But this one will always be an open circle because it came from the denominator. So now I need to choose values that are between these two. So remember, this would be, oops. Okay, so on my number line here, I need to choose anything between, because I've got these 3 intervals here. So for interval 1, I can do anything less than negative 3. I don't want to choose negative 3 itself because that's my critical value. So let's do negative 4. So negative 4 plus 3 over negative 4 minus 5 should be greater than or equal to 0 if this is true. So that would give me negative 1 over negative 9, which is the same as positive 1/9, which is greater than or equal to 0. So that's true. So I would shade this portion. Okay. Because of that, this is most likely false, and this is most likely true. But again, let's check it. So if I put 0 in here, that would be 0 plus 3 over 0 minus 5 is greater than or equal to 0. Well, that gives me 3 over negative 5, or negative 3/5, which is not greater than 0, so it is false. Pick anything bigger than 5. It could be 6, it could be 7, it could be 10. Let's use 10. So 10 plus 3 over 10 minus 5, that would give me 13 over 5 is greater than or equal to 0, which is true. So we would shade this part. So my solution interval goes from negative infinity to negative 3, the square bracket, and then picks up again at 5 and goes to infinity with a round parenthesis, right? So there's my solution. All right, let's try one where we have a few more critical values. So we have x plus 7 on the top, x squared plus x minus 2 on the bottom. So the first thing I know I need to do here in order to find the critical values is x factor in the denominator. So I know that a is 1 and c is negative 2. So I need two numbers that multiply to negative 2 and add to 1. So that would be positive 2 and negative 1. So this would be x plus 2, x minus 1. So this time I have 3 critical values. I have negative 7 coming from the numerator, and I have negative 2 and positive 1 coming from the denominator. So I actually have 3 critical values. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So here are my inequalities, or here's my number line. So I'm going to circle my critical values. Again, I have 3. The one from the numerator, I look at this inequality, and because there's no equal sign, I know it's going to be an open circle. These two will always be an open circle because they came from the denominator, and I cannot have my denominator equaling 0. So this time I actually have 4 intervals. I have one over here that goes from negative 7 to negative infinity. Sorry, negative infinity to negative 7. I have this one that goes from negative 7 to negative 3. Nope, negative 2. And I have the one that goes from negative 2 to 1. And then the one that goes from 1 to infinity. So this time I need to check 4 intervals. So from interval 1, I can choose anything less than negative 7. So let's do negative 8. So negative 8 plus 7 over negative 8 squared plus negative 8 minus 2. I could also put it in here. I could do that form, the factored form, that would work as well. So that would give me negative 1 on the top. This would be 64 minus 8, or actually just minus 10. Because minus 8 and then minus 2 more. So that'd be 54. So negative 1 over 54 is less than 0 because it's a negative number. So this is true. So because it's true, I want to shade this part of my number line. Okay, from negative 7 over. In this second interval, I can choose any of these numbers in here. I'm going to try negative 5. So if I put negative 5 in here, I'm going to get negative 5 plus 7 over negative 5 squared plus negative 5 minus 2. So that gives me 2 on the top. That would be 25 minus 7, which is 18. And 2 over 18 is a positive number, so it is not less than 0. So that one is false, so I would not shade that section. The middle section here, I'm going to choose 0 because it's easy to calculate, right? If I do 0 plus 7 over 0 squared plus 0 minus 2, that gives me 7 over negative 2, which is a negative number, which is less than 0, so this is true. So I would shade that one. And then for my last one, I would plug anything bigger than 1 in. I'm going to try 2. So 2 plus 7 over 2 squared plus 2 minus 2 is 9 over, that'd be 4, plus 2 minus 2 would be 4. So that one is false because 9/4 is not less than 0. And that is usually the case. They usually alternate. So the solution interval would go from negative infinity to negative 7. And then again between negative 2 and 1. Okay. Let's just go ahead and do one more, just to be thorough here. I've got x plus 1 over x squared minus 16. So I do need to factor this denominator. Remember, this is a difference of perfect squares. It's x squared minus 4 squared, which means it can be written as x plus 4 times x minus 4. So the critical value from the top is negative 1. The critical values from the bottom are negative 4 and positive 4. Because these came from the denominator, these are going to be open circles. This one came from the numerator, so I would check my inequality, and that's going to be a filled in circle because of my equals there. So I've got 1, 2, 3, 4, 5. I've got 1, 2, 3, 4, 5. And I'm going to circle negative 1 with a filled circle. I'm going to circle negative 4 with an open circle and positive 4 with an open circle. So that means my number line has, again, 4 different intervals that I need to check. I need to do 1, 2, 3, and 4. So for this first interval, let's put negative 5 in there. It could be anything that's less than negative 4. So negative 5 plus 1 over negative 5 squared minus 16 equals negative 4 over 25 minus 16 would be 9. So negative 4/9, and it says greater than or equal to 0 in my inequality. So that is not true. So this is our false interval, a false interval. In interval 2, I can choose any number in here. I'll do negative 2. So negative 2 plus 1 over negative 2 squared minus 16 is negative 1 over 4 minus 16, which would be negative 12. If I divide a negative by a negative, it becomes positive. So 1/12 is greater than or equal to 0, so this interval is true. Choose one between negative 1 and 4. Always choose 0 if you can, because it's pretty easy to calculate if you're putting zeros in for x. So 0 plus 1 over 0 squared minus 16 should be greater than or equal to 0. 1 over negative 16 is a negative number, which means it's not greater than or equal to 0, so that one is false. And then choose anything 4 or bigger. So let's put 5 in there. So 5 plus 1 over 5 squared minus 16 is 6 over 9, which is greater than or equal to 0. So this one is true, and I would shade that. So my solution interval goes from negative 4 to negative 1 with a square bracket around negative 1. And then again picks up at 4 and goes to infinity. Okay, so give some of these a try, and if you have questions, you can email me, or I will be back tomorrow.